I'm Jason Hintersteiner from Comcast Business. I'm going to start talking about a Brewster's Millions story of Wi-Fi deployment. For those of you who are familiar with the movie from the 80s, there actually have been several versions of it. The book was written about 120 years ago. There have been several versions. My favorite is the one from the 80s because I'm a child of the 80s. And I'm here to tell you that you don't actually have to be crazy to deploy thousands of APs in 30 days, but it helps. And so what do I mean by a Brewster's Millions story of Wi-Fi deployment? This is where you're highly constrained in time, and you have a huge number of APs that you need to deploy in a very limited amount of time. So you have a very short window in which the property is going to be unoccupied, and where you can actually get in and deploy all of your APs, your network switches, your routers, everything else that you need to deploy. The network's got to be working at the end of that short window, and this upgrade is mission critical. There are several different environments where you can run into this type of Brewster's Millions deployment, where I have a lot of APs in a very short amount of time to do it. Stadiums, K-12 schools, universities, student housing, factories and warehouses, retail chains, and there are probably a bunch of others that one could think of. Now, I'm a systems engineer by background, so I think in terms of requirements and constraints. So you'll see this in probably all of my presentations. I always have a slide on requirements and constraints. Requirements are what you need to do. Constraints are what you have to live with. So typical requirements are coverage, usage, what kind of devices you have, right? How do I have to segment the network? What kind of applications are going to be going? Do I have high availability requirements? And then capacity. How many users do I actually need to support? And that can vary by area. So I could have areas of heavy usage versus light usage. And you may have a usage profile where at certain times of the day, the network is more busy than other times of the day, depending on the vertical. Typical constraints, in this case, we're talking about time, where we're very limited in time. Right? We may also be limited in what are available internal resources to actually go, deploy this thing. Can you guys still hear me? Yep. Okay. Price and cost, this is always a constraint. The physical architecture, right? You're constrained by how's the building laid out, what building materials it's made out of. And then what information you get from the customer. And sometimes this is not always 100% accurate. So what they tell you on the plans, and then when you show up and what you actually see, can be very different things. And it's not just where the APs are, but when you're doing an upgrade like this, you have to worry about everything in the core and everything in your distribution network on the wired side in order to get all of this working. So I'm going to select my technology and my design based on what those requirements and constraints actually are for the project. So I'm going to start, right? I work for Comcast, right? We provide bandwidth, right? So underlay circuit bandwidth is a huge, how much capacity do I need? Do I need to have multiple circuits in? Do I need to have multiple circuits in from multiple providers, right? For an extra layer of high availability? Is it multi-site? So do I need SD-WAN, right? Then, of course, I've got a router that's got to handle all that bandwidth. And I may have high availability, so I may need multiple routers and multiple core closets that have to talk to each other, right? Any external core servers that I have to support, DHCP, DNS, right? Maybe some customer-specific ones. Obviously, I have to pick a switch and AP vendor, right? Am I going to go with Wi-Fi 6, Wi-Fi 6E, Wi-Fi 7? And again, that will depend on the device types, the capacity, and the applications, right? The core and edge switch technology that you use, right? In order to, we've been talking about, do I need multi-gig on my APs? Well, if I need multi-gig on my APs, I need multi-gig on my switches, and I need a lot of bandwidth capacity on the core. So now I'm looking at 25 megabit backhaul, 25 gigabit backhaul, 50 gigabit backhaul, 100 gigabit backhaul on the switches on the internal LAN network to connect the switches to each other. Cost, obviously. And then, as we've lived through the last few years, equipment availability from vendors. Thankfully, this is a problem that's mostly solved, but this can be an issue, especially if you're ordering, a lot of high-end equipment. So, time and resources. How do you handle this? Do what you can in advance. As much as possible, do what you can outside of that limited time window when you're actually on site installing APs. Capture your requirements and constraints. Perform predictive modeling, right? Develop your IP schemes. Site survey if you can. Sometimes you can't, thanks to Lee. Test any new technologies, right, that you're debuting for the first time in order to make this network work. And if possible, pre-provision your equipment. Right, and then align your resources to actually match your install window. This is not just engineering on the design side, but this is your project management, your site surveyors, right, and then your installation and deployment team. Know your core infrastructure, so know where your bandwidth is going to go, right? If it's high availability, which is often the case in these types of mission critical applications, you've got 2 routers in 2 separate locations that are virtually stacked. You've got core switches in those 2 locations that are virtually stacked to each other. So all that's got to be worked out. Locate your distribution zones, because often you have your MPO, which is your main point of entry for the circuit. It may then have core closets that affect different zones of the property. And those areas, as we discovered the hard way on a particular project, we had one that was divided into 4 different zones, but the zones actually were uneven. So one of the zones had 60% of the network. So you need to account for that in the design. And then you need to support, as I said, 25 gigabit links, 50 gigabit links, 100 gigabit links, right, between those switches. And then finally, you have your edge connections in each of your buildings, where now I need support for 1 gigabit, 10 gigabit fiber, Ethernet connections, and especially, maybe 25 gigabit if I need to support multi-gig on my APs. Existing infrastructure. So guess what? You're going to wind up reusing it, right? But understand, the limitations of that design. That's why I recommend modeling this stuff as far as you can in advance. Obviously, if you have too few existing APs, you're going to have coverage gaps. If you have too many APs, right, I'm going to get a lot of self-interference, right? We know the old adage, more APs does not necessarily equal more capacity. Every building and location on the network will have unique layouts. So you may have a mix of hallway deployments, in-room deployments, in-suite deployments, places where I can put stuff on the ceilings, places where I can put stuff on the walls. Again, this is a concept that I've talked about before about mass customization, which is basically saying, all right, I have a set of tools, I have a set of APs and switches and such, and it's the same set. This is the set I'm going to play with, but I'm going to tailor it for each environment that I'm in, and I have to do that in advance as much as possible. And you want to minimize the need for recabling. Now, you may wind up going into an environment that has some really old infrastructure like Cat5 or Cat3. So you may need to run additional cables for additional APs, and you may need to convert coverage. So say you had a dormitory with hallway coverage, and now you want to have in-room coverage. Well, somebody's going to run those cables into those rooms. You also will have unique applications and customer-specific requirements. So you'll have some unique devices. You'll have unique vertical requirements. You may need to not support wired ports anymore. That was one that had come up on a project this year. Provide systems to rapidly deploy or change or customize APs for different tenants at different times. And you may require another one that we ran into, very high bandwidth per user, where if you're promising over 100 meg SLA per user, guess what? You're using 40 megahertz or 80 megahertz channels, whether you want to or not, because you just can't get those kinds of data. You can't get that kind of throughput unless you're using big channels. That affects your channelization. So design, model everything in advance, review the floor plans for each building, right? Determine the wall types, identify low capacity versus high capacity areas. You can see in this example, these were literally the documents we got were circles drawn around the existing APs, and I indicated locations where, we have too much coverage, pull those APs out, right? Even though they're high capacity areas. Tweak the AP locations as needed, turn off 2.4 strategically, define the new locations where needed. And then create a plan. I'm a big one on having a static channel plan and a static transmit power plan. Implementation approach, when you that 30-day start, week 1, you're going to be surveying each site and building, right? Identifying all your locations, confirming AP locations, and so forth. You're also going to be provisioning and staging equipment. And then during those 30, in parallel, you're also going to be starting to install. So you're going to be surveying and installing, and on all these teams, you're going to wind up with multiple teams that are surveying, they're going to be installing the core, they're going to be running new cabling where it's needed. They're going to be, you might have a team that's just running around pulling out old APs, another team that's just installing switches, and another team that's running around installing access points. It's basically all hands on deck. So, you know, do what you need to do to get involved, right? If Fernay needs to borrow my hazmat suit, he's welcome to it. But it doesn't end at the end of the 30 days, because when you're deploying that fast and that many APs, stuff is bound to go wrong. You got to look at physical layer, right? All your layer 1 connections. Is your cabling good? Especially if you're reusing cabling, that cable, you know, are their terminations good? Equipment troubleshooting, you know, we ran into firmware issues on routers, switches, APs. If it can go wrong, it will go wrong. Of course, it's DNS, right? It's always DNS, right? And then, you know, switch stacking issues if you're doing high availability and so forth. And then finally, network optimization. After the fact, right, you're probably going to be going back in there and tweaking channels and optimizing power and you know, utilizing AI tools if your vendor supplies it in order to kind of tweak the network. So all of that's going to happen after the 30 days, right? Because it's not going to just work at the end of the 30 days. Thank you.